All right, if you're still sweating from that last example, take a deep breath. I want to look at two that are less complicated, at least algebraically, and these are more on level with what we'd expect in an AB level course. So if we take a look at number 12, we want h of g of x. I'm going to go ahead and let h be green, and we will let that g be blue. So the order matters here. I'm taking the function h and substituting the function g into it. So that means my function h is going to have an x minus 1 substituted into it. Everywhere there used to be an x in that function h, there will now be an x minus 1. Well, my function h is just 5x minus 3, so that is a 5. But now instead of an x, I have an x minus 1. So what we've done there is replaced x with x minus 1. So in the previous example, the algebra here got really rough. Note that that x minus 1 doesn't have a power in this example. This is just distributive property. 5 times x is 5x. 5 times negative 1 is negative 5. There's still a minus 3 tagging along. And we can go ahead and combine those like terms. If you owe your friend $5 and then they loan you 3 more, you now owe your friend $8. So that'll be 5x, negative 5 and negative 3 is a negative 8. Same process as that first example in terms of what we're doing with our functions, taking a function, substituting it into another function, but far less complicated. You take a look at 13, put a big X through it. And if you take a look at 14, we are now going to find g of f of x. So g, that is our green function this time around. We'll go ahead and let f be our blue function this time. So what that is asking us to do is take g and substitute f into it. And if this is giving you the heebie-jeebies, note that the order has shifted from that first example. In the first example, I did f of g. I am now doing g of f. They really are different things. And the reason I wanted to go through that first example is to illustrate how different they can be. That first one was rough. But g of f, well, that just means I'm going to take g and put this cubic into it. And g of that value just means I'm going to take g, which is x minus 1, and replace that x with an x cubed plus 8. Well, there's nothing to do in the parentheses there, so all I have to worry about is that plus 8 and that minus 1. 8 minus 1 is 7. Order really matters when we're talking about composition. In that first example, when we did f of g, look at all the work. When we come down to this last one, when we switch the order, g of f, I get a totally different function that algebraically couldn't have been further from this giant FOIL followed by a trinomial times a binomial. This one was just subtraction. So keep in mind, these can be very different problems. The order does matter. I want to take a look at two where we actually involve a number, 15 and 16 here. Note that we are using the same functions as before, f, g, and h there. And now we're just going to substitute in values. So let's take a look at 15. I will let g be blue, and we'll let h be green. And we are going to use that definition. What does g of h mean? Well, it means I'm taking g and substituting h of, oh, now there's a value. It's not just an x. Now I'm substituting h of 2 into g. So keep in mind we're plugging in values now, actual numbers. H of 2 is a number. It's no longer a function. So h of 2 means I'm taking my h function, which is 5 times x minus 3, but x is now 2. 5 times 2 is 10. 10 minus 3 is going to be 7. So I'm going to take g of 7. Again, that 7 is our h of 2 value. We took one function and evaluated it at 2. We're going to use the output of that function to evaluate g. G is just x minus 1. So what that means, I'm going to take that 7 and subtract 1 from it. 7 take away 1 is just 6. Looking at one more example. Now I'm using f. So we'll let f be. I'll use the highlighter purple and actually do the math here. We'll go ahead and make that red, a little bit easier to read. So we have h of f and f is that guy, and h will be green. So note what this is telling us to do is take our function h, and we are going to substitute f into it. But instead of x, we are substituting in the value -6. So f of -6 means we are going to take that f function, which is x cubed plus 8, and we are substituting -6 into that function. Well, -6 cubed, that's our -216, and if we add 8 to that, we get -208. So we are going to evaluate our function h at -208. So note -208, that is an output value. That is the output of f of -6. That -208 is the output. It's now the input for h. So I'm doing f first to get that output value, and now that output value is getting substituted into h. So h is 5x minus 3, and keep in mind that x is now -208. So -208, we'll also do that minus 3. This is absolutely one where I had to pull out a calculator. 5 times -208 minus 3. You could put that whole thing into your calculator at once. Most calculators can handle that kind of arithmetic, no problem. That's going to be a -1040. So that's the end of the function compositions material. Try out those practice problems. Let me know where you're stumbling. If you're having trouble with the arithmetic, keep in mind FOIL can come back, distributive property can come back. And then there's also all of these numerical examples where we just need to be careful about order of operations. So let me know what kind of help you need and get to work. See you soon.